Prospect is a company that are interested to have good products, functionally good products, and they want to make sure that the public, the customer, gets the right information.
The biomechanical testing of athletic footwear gives us insight into how the shoes are affecting the user while they are running. From there, we are able to look at certain variables that may be correlated with performance or injury aspects, such as higher moments at a certain joint.
The shoe has basically two main construction. Here, the lower part is the ground interface, and this upper part is primarily relevant for support.
So for data collection for this project, we used 28 subjects. We used both men and women, 14 of each, and had them run and power walk within the Prospecs shoe as well as the competitor walking shoe and a running shoe that's currently on the market. They complete 10 power walking trials and 10 running trials in each of the shoes. During those trials, we're able to collect biomechanical variables, including marker positions to calculate the moments, angles, and velocities at the joints of the lower extremity, as well as collecting muscle activity data using electromyography.
The first thing that we do always is we measure the movement. What we do, we put markers on the subjects which are glued to the human leg at different locations that are predefined. And these markers are reflective, and that allows us to reconstruct the movement in 3 dimensions.
To test the toe-out angle, we would then look at the alignment of the foot compared to the lab coordinate system to see if there was a difference between, as stated, if the toes were pointing more outwards or being able to line up straight. We did find that the Prospecs shoe, in fact, did make the toes more straight and more toe-in, lining up with that axis during the stance phase.
The second step, we measure the forces in the ground, so between the ground and the test subject.
To investigate whether Prospecs shoes had an effect on impact absorption, we investigated the vertical ground reaction forces during walking. From there, we were able to see that the Prospecs shoe would decrease the peak loading at the impact peak of walking during the stance phase, supporting the claim that absorption was improved with their shoe.
The third step is that we can combine those two and calculate up the body and calculate the loading in the ankle joint, the loading in the knee joint, the loading in the hip joint, or wherever we are interested.
So to investigate whether Prospecs shoe did in fact have an effect on the angular displacements and moments, we would look at all 3 planes of motion in the angles, angular displacements and moments. From there, we were able to see that the Prospecs shoe reduced the angular displacement and reduced the moments as well within the ankle joint and the knee joint.
The last measurement that we do is muscle activity. We measure muscle activity throughout the whole body.
With energy return, in order to determine this claim, one aspect that we can look at that correlates possibly to energy return is muscle activity. However, we were unable to prove that the Prospecs shoe showed a difference within muscle activity between the competitor shoes, but there was a trend for the Prospecs shoe showing increased muscle activity compared to a competitor walking product. I think in general, for showing the testing and confirming the results that athletic footwear are making in these days is beneficial, just that people see where the results are coming from, and just gives individuals a better idea of what's actually happening and why these claims are being made and how it might be beneficial for you to understand what the benefit of a certain claim is.
The study that we did was quite a comprehensive study, and the most exciting result was the result of that alignment of the foot. Nobody has ever tried to affect that. That's the first in the history of sport shoe development.